Okay, so to really understand what we're looking at today, we actually need to rewind a few centuries. Picture this. It's the 17th century. An English writer named Rice Vaughan starts noticing something, kind of alarming. Basically, everything in his native land is just getting more expensive. But he's stumped, right? Because how do you actually prove that prices are rising across the board? Well, fast forward to 1707, and another economic detective, William Fleetwood, publishes Chronicon Priceism. He goes in and directly compares the prices of everyday things, wheat, oats, cloth, meat, from the 1400s all the way to the late 1600s. Pretty groundbreaking. But the real breakthrough, that happens in 1764 when an Italian named G.R. Carli creates the very first recorded index number using a simple average of price relatives.
And honestly, that 300-year-old pursuit leads us right to a core question we still grapple with today. How do we actually measure the changing cost of living over time? You know the feeling. You go to the grocery store, check out, and just feel like your wallet is lighter than it used to be. But how do economists turn that gut feeling into hard, undeniable data?
Well, welcome to The Explainer. I am so excited to dive into this with you today because we're going to unlock one of the absolute most powerful tools in all of economics, index numbers. By the time we wrap up, you'll know exactly how the experts track the massive shifting tides of our global economy. Let's get into it.
Section 1. The price change problem and what are index numbers.
Okay, let's start with a formal definition from the economist Spiegel. He states that an index number is a statistical measure designed to show changes in a variable or a group of related variables with reference to time, geographical location, and other characteristics. Sounds a bit dense, right? So what's the actual takeaway here? Basically, an index number isn't just some random standalone statistic. It's a highly specialized average, usually expressed as a percentage. It's designed to capture the net change of things like, say, your monthly grocery bill or even national income over a specific period. It takes the total chaos of millions of changing price tags and distills the whole shebang down into one clean, digestible metric.
But here's the thing, you literally cannot have an index without a point of comparison. First up, we have the base year. In economics, this is denoted by the suffix O. The base year is our anchor. It's the reference year that we assume has a perfect normal value of 100. Opposing that, we have the current year, denoted by the suffix 1. This is our moving target, the specific year we're actively trying to measure. So to put that into perspective, if we're looking at the price of cars today compared to, let's say, 2010, well, 2010 is our base year O, sitting comfortably at 100, and today is our current year 1.
Section 2. Measuring the economy's health.
You'll often hear economists refer to index numbers as the barometers of economic activity. And why is that? Well, just like a meteorologist uses a barometer to predict a massive storm rolling in, policymakers use index numbers to study huge trends, frame economic policies, and forecast future economic activity. So whether a government is trying to fix minimum wages based on the cost of living, or they're predicting future export trends, they absolutely rely on these barometers to make informed, data-driven decisions.
Now, as you might guess, a single tool can't measure absolutely everything. We've got an entire toolkit of index types. First, the price index number. This one compares general changes in the prices of goods between two periods. Next up is the quantity index number, sometimes called a volume index, which measures changes in physical output, like agricultural or industrial production. Then we have the value index number. This one is super informative because it multiplies price by quantity to measure the total value of a variable in dollars, euros, rupees, or whatever currency you're tracking. And finally, special purpose index numbers. These are totally custom built for specific needs, like tracking labor productivity or stock market share prices.
Section 3. Building your own index.
So, how do we actually make one? Think of index construction kind of like a very careful baking recipe for economic data. First, you have to determine your exact purpose and scope, like what exactly are you trying to measure. Second, you select your base year. And here's a really fascinating detail from the sources. The base year must be considered normal, meaning it should be totally free from natural calamities or extreme economic shocks, and it shouldn't be too far back in the past. Third, select representative items. You obviously can't track every single item in existence, so you pick a sample that accurately reflects the tastes and habits of the people. Fourth, gather unbiased price quotations from reliable agencies. Fifth, choose a suitable average, usually the arithmetic mean, just because it's simpler to compute. And finally, step 6, assign proper weights, and we're going to explore that one deeply in just a second.
Section 4. The math behind the magic.
All right, let's start with the simple index method. It is exactly what it sounds like. Every single commodity gets equal importance. If we want to find a simple price index, it's really just like solving a puzzle. We take the sum total of our current year prices, that's P1, and divide it by the sum total of our base year prices, which is P0. So looking at commodities X and Y here, we'd add the current prices, 12 plus 20, divide that by the base prices, 8 plus 10, and just multiply by 100 to get our percentage. It's incredibly straightforward, but, as you might notice, it assumes commodity X and commodity Y are equally important to our daily lives.
But in reality, we know not all goods are created equal, right? I mean, a massive price jump in daily staples like rice or wheat is going to matter way more to your wallet than a price jump in a minor commodity, like some rare luxury spice. That's where the weighted index number method comes in. It assigns relative importance to these items in your proverbial shopping cart. Economists use some pretty specific formulas for this. For example, the Laspers method uses base year quantities as the weights, essentially anchoring the index to our past consumption habits. Alternatively, you have the Pache method. That one uses current year quantities, which reflects current consumption much better, but honestly, it can be a real headache to calculate year over year. Ultimately, though, weighting gives us a much more accurate reflection of real-world economic impact.
Section 5. Flaws in the formula.
Now, as indispensable as they are, we have to admit, index numbers are definitely not flawless. For one, they often totally ignore qualitative changes. Let's say a smartphone is more expensive this year than it was 3 years ago. A simple price index just registers that as a price hike. It completely ignores the fact that the new phone has a vastly superior camera and a way faster processor. I mean, a better quality product naturally costs more to produce. Second, those weights we were just talking about, they can actually be quite arbitrary and subjective depending on exactly who is constructing the index. And finally, they have a limited scope. An index carefully constructed to measure agricultural output absolutely cannot simply be repurposed to measure urban living costs. It just doesn't work that way.
Which brings us to a final thought for you to ponder today. If an index inherently struggles to capture how the quality of our products improves over time, are we really measuring the true cost of living or just the cost of existing? The next time you hear a news report casually talking about inflation or industrial output, I want you to think about that base year, the weights in the shopping cart, and the invisible quality upgrades hiding right there behind the numbers. Thanks so much for joining me for this explainer, and keep questioning the data.